It's going to be our measuring device. It's a 10-foot long piece of EMT. We're showing you the distance with a tape measure. We're going to be working at 10 foot. All right, this is our test bag. We have sand that's less than 10% moisture content. Rigged to a forklift using a nylon product and a quick release device. The test procedure is basically going to consist of raising this unit 10 feet off the ground, using the measuring stick that you saw earlier, placing it over the sample to be tested. At that time, the forklift will be secured in place. No one will stand underneath the load. The rope will be pulled, quick release, and the sandbag will drop on the sample, and we will see what the results are. These are the samples we're going to test. We've got several varying things that we find on the job site. John, why don't you explain these three items here and what your thought process was for these and why we want to test these items.
Okay, what I have going here, what my concern is that I have seen letters of interpretation or clarity stating that a day hook for 180-degree bend is acceptable as impalement protection at grade, and our purpose here is to see if indeed that is true. What we have here, one of the letters states that a bar with a 90-degree bend on it and a standard hook is not acceptable because it still leaves the potential for impalement if a person were to fall against it in this way. I've gone ahead and I want to do the testing anyway because I would like to see what the results are if the test bag dropped on these right angles, what happens as far as impalement is concerned from a vertical level.
Okay, so this is a 90-degree bend with what number of rebar?
This is number 4 bar with what's considered a standard hook for number 4.
This is sample number 1.
In all the samples, they're arranged in a manner so that we have a group of 3 bars together that would represent a wall or a continuous run of reinforcing steel with the right angles of hooks or whatever the condition is, and then a single bar by itself. The purpose here or intent is to drop the bag over the group, see what would happen in that condition, and then also to drop the test bag over an individual bar to see what the results are.
Okay, that's sample number 1. Sample number 2 is this device right here. John, explain what this is, the part of the matter.
Sample number 2, we've got number 6 reinforcing steel with the standard hook. Mike, we should probably get your tape measure. We'll see what the distance is across this radius. It's approximately 5 to 6 inches, but we can get an accurate measurement on that. And again, it's the same basic principle. If we had a continuous row of bars, we've got 6 inches out on the number 6 bar. The same basic idea is going on here.
This is sample number 3. John, why don't you explain what this is?
Sample number 3 is the same basic principle, except it's a number 5 reinforcing steel, and the standard hook dimension on that is approximately 5.5 inches. So these are the conditions that you see out on the job site: number 4s, number 5s, and number 6s, as they relate to a standard hook with 185-degree bend.
The number 5 is sample number 3. Okay, sample number 4 is your standard form stake. John, why don't you explain your principle to that, what we're going to do with those?
My concern with the grade stakes or form stakes is that they are not necessarily, or perhaps I should say not consistently recognized as impalement hazards. Some people view them as strictly a tripping hazard. My concern is that they are indeed an impalement hazard. So we will be driving these stakes into the ground, depending on what we can get in the depth of the soil. I'd like to see about a 10-inch protrusion from the soil on the grade stake. We'll drop the test bags accordingly and see what the results are.
These grade stakes, sample number 4, 6.5 by 3/8 inches in width. This is sample number 4. Sample number 5, John, can you explain what sample number 5 is?
Sample number 5 is a similar situation as far as recognizing things as an impalement hazard. We will be dropping the bag onto these anchor bolts that I believe are 5/8 of an inch in diameter, and we will see whether or not they are impalement hazards or should be protected accordingly.
Out of that.
Yeah, they're about a 6 3/4 inch protrusion above this plate.
there, what's the diameter on these bolts?
These are 5/8 diameter bolts.
5-inch diameter bolts. This is sample number 5. Sample number 6 will consist of a piece of EMT, which is used for electrical lines. It's 3/4 inch diameter to schedule 80 stuff. It works real well. It's very common in the trades. I got this piece from a local electrical contractor, which tells me this is the most common stuff they use. We'll have it treat at least 10 inches out of the ground so that it can do a content on this. This is sample number 6.
I think one of our concerns with this is quite often we will see this EMT conduit used as a standard or post for barricade tapes and things like that. Caution tape.
And our concern is this an impalement hazard? Because we run into this issue a lot too. Yes. These are the most common types of items that we see on a job site: conduit, the bolts, the rebar, or the grade stakes, and then of course the rebar bends. We try to pick a good cross section of things that we typically see on a job from our experience. So we'll test those items.